Good evening and welcome to the AWS Canberra User Group for October 2021. Before we get started, we'd like to acknowledge the traditional custodians of the land we're presenting from, the Ngunnawal people, and pay our respects to their elders past and present. This evening at the user group, we will have our usual array of things that were new releases for the month, as well as our new white papers that have come out. And very excitingly, we've got both Ben and Aaron from a very good AWS partner, Shine Solutions, here to talk us through the TGRS stack, the government edition. Now, before we get into that exciting stuff, please go and check us out on YouTube. You can find all our previous shows up there. Please subscribe. We really want to get to a unique URL that's all our very own rather than this one. But please go and subscribe and tell your friends. In terms of what's happened that's new this month, so we've got 126 features or releases this month so far. We've still got a few days to go, so we'll probably get a few more in yet. What that looks like in a graph, trending down a bit at the end as you see. And as you'll see, there's a bit of a pattern in this graph, and that's because it's almost time for reInvent, which is basically Christmas in November for all us technologists. So the URL's there, go and register. It's our premier education conference. There's lots of really great content. It's going to be both in person and online this year. So you can go along, register, watch all the keynotes and get a whole bunch of the breakout sessions that will all be recorded as well. Really great content. As I said, our premier education conference each year. So absolutely recommend that you go and A, sign up, and B, get involved in some of those sessions. In terms of some of the key new releases, we've got a few for you this month. The first is kind of 3 sneaky releases in one line. So Code Guru's announced a few things this month. The first of those is some security detectors for Python applications. So what this will actually do is provide recommendations against things like the OWASP Top 10, AWS service best practices, and things like that as you're doing code reviews in Code Guru. The second part of that for Python applications is it will also do security analysis using an open source tool called Bandit, which gives you another common platform for assessing your Python code available in Code Guru. The findings out of Bandit, they'll be surfaced in the different parts of Code Guru for you as well, either in comments, etc., like that. The other release this month from Code Guru is another integration with an open source tool, this time Infer for Java applications, which will give you an additional code recommendations with your Java applications. AWS Firewall Manager now supports centralized logging of AWS network firewall logs. So AWS Firewall Manager is our service that allows you to control and manage your firewalls centrally throughout your organization. Using this feature, you can now centrally log the network firewall logs to your firewall administrator account, and you can do it in a way where you describe a policy and the accounts that you select in that policy have their logs aggregated. So it's a very good way to gather the logs centrally that you want to gather. EC2 Mac instances are now available in additional regions. The reason we've got that there is one of those is Sydney. So you can now, if you're developing applications in the Apple ecosystem, you can now go and spin up an EC2 Mac Mini on demand as you need it and get all the cost benefits of running that in AWS and do that now in Sydney, which is great. If you're a user of Amazon Fraud Detector and the online transaction fraud detection models, so these detect card not present fraud, there's a new model that's been made available, and this is actually captures up to 30% more transaction fraud than the previous model. And so really great gains there, worth checking out. The distributed load testing solution from AWS is now at version 2.0. So this gives you a pre-canned template that you can go and roll out and customize to do your load testing of your applications. It's got great documentation, all the stuff you need to get started, and the version 2.0 release is well worth looking at. Security Hub now supports cross-region aggregation of findings. So for us, this is going to get much more important, these kind of cross-region releases with the upcoming release of both Melbourne and the newly announced Auckland region. So super exciting for us in this part of the world where we're seeing more services take advantage of these cross-region capabilities. AWS Fault Injection Simulator now supports spot interruptions. So Fault Injection Simulator allows you to simulate failures in your AWS infrastructure, allows you to, and this new release, allows you to inject faults into spot instances within that infrastructure. So you can go and now simulate the termination events of spot instances as a part of running fault injection simulations through that service. So within a few clicks of the console, you can start running entirely new simulations through that. QuickSight now has Spice incremental refresh. So previously, Spice, which is our super fast processing in-memory calculation engine. Previously, you've had to do a full refresh of your data set, and that could take up to hours to actually happen. So now with this incremental refresh, you can get refreshes down to incremental updates of data every 10 to 15 minutes into there, and to save you hours of time and keep that data fresh in memory. Backup Audit Manager now has compliance reports. So as a part of this, you can get your AWS backup resources and the different policies you've got applying to back up your resources. You can get reports on how well the backups are complying with your organization's requirements and the different policies you've got enforced. And those reports can be dumped out to S3 so that you can take advantage of them and look at them later as well. And Amazon Neptune now supports auto-scaling for read replicas. So what this allows you to do is you can actually set in Neptune auto-scaling based on, say, a CPU metric or another CloudWatch metric. And based off that, you can scale out your read replicas for Amazon Neptune. So as the usage grows, it'll automatically take care of that for you, which is really nice from a read replica point of view. White papers this month, 16 of them so far. A few key call-outs is the first one around multi-tier architectures with API Gateway and Lambda. This has some great reference architectures on how you can go and build 3-tier applications using API Gateway, Lambda, and AWS services that way. The second one around, it's got a heck of a name, so I won't read it all out here, but this is an example of one of the reference architectures you can go and get out of our white papers, and it gives you a centralized network architecture for providing internet egress with NAT gateways and transit gateway. And lastly, we've got an IPv6 on AWS white paper, which is a brand new white paper around adopting and designing IPv6-based networks in AWS. And with that, at this stage, we're going to just take a quick short break while we cut over to the team from Shine Solutions, and they're going to talk us through introducing the TGRS stack. So hang around for a second and we'll be right back.
Hey everybody, and thanks for coming along tonight and checking out our presentation. This is actually going to be 2 presentations by myself and Aaron. I'm going to start off by giving an overview of what we call the TGRS stack at Shine. And then Aaron's going to come in and talk about how we applied that stack at a government client and some of the things that he had to do to fit in with their special needs. But I'm going to get started right now with just an introduction to the stack. So TGRS is a stack that we've used on numerous projects in the enterprise to build user interfaces. And it stands for TypeScript, GraphQL, React, and Serverless. Now, before I go any further, let me just be clear that when I say serverless, I mean the general idea of serverless infrastructure, not the serverless framework, if you've heard of that. Now, TGRS had a couple of motivations that came about from years and years of us building user interfaces at Shine. And I guess the first one was just completely out of control JavaScript code. I think that one thing that I've thought about JavaScript in the past is that big JavaScript projects can be a little bit like small children. If they're your children, if you're the parent, then they are perfect and beautiful. But to everybody else, they really just make no sense whatsoever, and they're unpredictable and might even smell pretty bad. And we were getting a bit tired of having to deal with this over and over again. Our second motivation for coming up with the TGRS stack was getting out of control data loading code in our client. So we would end up in situations where our client was just making calls to lots of different REST endpoints, getting lots of different sets of data, sometimes making multiple requests in response to a single user interaction. and sometimes just getting massive payloads that it didn't really need to get all of. And all of that logic was ending up in the client and making the client loaded as well. And this was not a good thing. The final big motivation, and this is sort of the reason I'm here tonight, really had to do with, out of control infrastructure. Because I've had many times when I built a web application and I wanted to deploy it, and it's really just a set of static artifacts. And I've maybe gone up to some infrastructure people and told them that I want to deploy it. And they've said, well, you're going to need to run Nginx, say, in a container, front it with, run it inside ECS, front it with a load balancer. And all I really want to do is serve up some static assets. And so we're getting a bit tired of that happening, and thought that we'd look at serverless infrastructure and see if it could help us out. So just a high-level overview of the TGRS stack. Really, there's kind of two main parts to it. At the front, we've got a CloudFront distribution that is serving up a React client by HTTPS to the user's browser. And then we use GraphQL to talk to a Lambda function via API Gateway. And inside that Lambda function is a GraphQL server. Commonly, we use Apollo server to do this. Both the client and the GraphQL server are written using TypeScript. And in this case, although TGRS is kind of cloud agnostic, this is an AWS meetup, so we'll talk in terms of AWS. And then what happens is that GraphQL server kind of acts as an aggregating layer to a number of services further upstream. They could be REST services, or they could even be other GraphQL services that are federated in. Now, this stack has a couple of key properties. The first is that we're building a UI here. And I've kind of reached the conclusion, at least, that when building a UI developers have to still think in terms of a client and a server. You can't really have front-end people and back-end people. If you're going to end up with a performant application that is easily maintainable, UI developers need to own both a client side and the server side of the application. And that's a really important philosophy and mindset that you need to adopt when using a TGRS architecture. The second key property is that we have TypeScript absolutely everywhere. And the reason for that is that TypeScript really kind of acts as a bit of a nanny for our naughty JavaScript code bases and kind of keeps them under control, keeps them manageable. And it could be a little bit of a burden at first, learning TypeScript, but I'm pretty much at the point now where I'm not sure how I worked without TypeScript beforehand. It's something that I will use for just about any task, big or small. The final big property of TGRS is that we use serverless technologies wherever possible. And that, the way in which we do that can vary from place to place. And as you'll see from Aaron's talk later on, we do have to make some compromises. But ideally, we're using serverless as much as we possibly can. So we'll drill in a little bit to some of these technology choices. Now, because this is an AWS meetup, I'm not going to delve too much into the T or the R in TGRS. I'm going to focus mainly on the G and the S, the GraphQL and the serverless. But I will just say a couple of quick things about TypeScript first. Really, TypeScript is scalable JavaScript. It's JavaScript tooled for large JavaScript code bases. But if you haven't used TypeScript before, I think it's important to know that whilst it's possible to incrementally introduce it to projects, to get the most benefit out of it, there's a couple of important flags that you should switch on when you're using it. The first is called no implicit any. This is a compiler flag that will pretty much force you to specify types to all of your function arguments, rather than it just defaulting to letting you pass any type through. To be perfectly honest, if you're not using this flag, you really aren't getting most of the benefits of using TypeScript. So we highly recommend it. And it's hard to introduce later on. We recommend just biting the bullet and doing it from the start in the project, because this type information will encapsulate the intent that programmers have when they write code. And if you leave it out and try to put it in later, you've got to go back and figure out what their intent was. The same can be said for a flag called strict null checks. And this is a flag that means that TypeScript will detect whenever you've got an object that is undefined or null. And if you're trying to do something with it, it thinks you're trying to do something with it, then it won't let you do it. It will complain. And this lets you avoid an entire class of runtime errors. What would be in Java the stereotypical null pointer exception. And it's difficult to overstate just how much impact this can have on your code base. Again, really hard to retrofit into a code base, though. I recommend you just bite the bullet and do it from the start. It can feel a bit weird if you're not used to it, but it rapidly pays for itself, so to speak. Next big technology in the stack is GraphQL, and this is one I want to dig into a little bit. I mentioned earlier on that using a TGRS stack requires UI developers to really take ownership of a client and a server. And that's, there's nothing new there. That's what we would have traditionally called a BFF pattern or a backend for front end pattern. And that's when you have a backend that is there to sort of meet the specific needs of a specific client, and only give it the data that it needs when it needs it. That said, doing BFF with REST can be kind of hard, can be hard to do right. Whereas GraphQL is actually a really good protocol for building backends for front ends, because it kind of gives you this mechanism for having clients that can efficiently and flexibly get the data that they need from the server. No more, no less, just exactly what they need. But you can evolve it very quickly over time. And that's fantastic. Another great thing about GraphQL is it is typed, and that complements TypeScript really nicely. You can even generate types for client queries or server schemas, the TypeScript types it is, from your GraphQL schema. And so this whole world of tooling becomes available to you. And again, that can help you avoid whole classes of bugs. That said, GraphQL does have a bit of a steep learning curve. If you're new to it, there's lots of new concepts to learn. So it is important to factor that in a little bit if you're starting on a project with it for the first time. The final thing that I want to say about GraphQL in the context of TGRS is that we encourage you to write your own server. And this is probably something I should specifically address, especially in the context of things like AppSync, sort of the GraphQL service that AWS provide. You can sort of layer on top of a data source. For the sorts of applications that we've built with TGRS, AppSync hasn't been such a good fit. And I think the reason for that has been that at Shine, we build applications for enterprises, and those enterprises are usually very complex. There are lots of existing back-end systems that we're dealing with. We might have the luxury of being able to introduce a few new data sources, but we're going to be going to an environment that is already very well established. It's not exactly greenfields. Offerings like AppSync generally let you drive a GraphQL schema from some data store. But to be honest, especially in an existing enterprise environment, that data store is not structured the way that you really would want it to be structured, but you're letting it drive your schema, then you can end up with a GraphQL schema that is kind of suboptimal. And it can even lead to situations where the client, and I've seen this happen on real projects, has to make multiple calls to a backend in order to get the data it needs in response to just one user interaction. And so in doing so, we're kind of working against the very purpose of GraphQL in the first place, which is a real bummer. There are mechanisms for customizing the use of, AWS's service. But, at least the last time I checked, we had to use things like velocity templates and so on, and they didn't work particularly well for us. What we propose instead is that you write your own GraphQL server using something like Apollo server. That kind of gives you the control to be writing this thing with real code, implementing your logic with real code. And Apollo is a very well documented and probably one of the most popular frameworks for building servers. I'd like if the situation was different, but certainly for big enterprise apps, that's been our experience. I'll just very quickly talk about React. Not the most critical part of this stack, but we do think that React kind of is a preeminent framework for building UIs because of its focus on minimizing state and side effects, which in our experience is kind of one of the biggest causes of bugs in user interfaces and the sources of confusion for developers over time. React also works really well with Apollo Client, which is sort of Apollo's client-side library for running GraphQL queries. And it also works quite well with TypeScript. We do recommend that if you use React, you use hooks, just because they're a really great expressive mechanism for reusing non-UI logic. But I won't spend too much time on React because this isn't a front-end meetup. let's talk a little bit about serverless. So I talked before about, or just before, about using Apollo server. I mean, the great news is that it's really easy to embed Apollo server inside an AWS Lambda function. There is one screaming exception to that, and that is GraphQL subscriptions. Apollo server can support GraphQL subscriptions, but not in a Lambda function, basically because subscriptions, if you're not aware of what they are, they're kind of like a push mechanism, crudely speaking, for pushing changes to a client, but that implies some sort of server-side state, which is exactly what Lambda functions are not. The one exception is you're not going to be able to use subscriptions. However, if you do need near real-time updates, there are other mechanisms that you can use. Apollo client can poll servers instead, for example. And so far, we've never really needed subscriptions for near real-time data in our usage of Apollo. Apollo server is also really easy to embed in different contexts. You can embed it in a Lambda function, or you can embed it in the Express server, sort of for local development, without having to run it in a Lambda emulator all the time. You can embed it in the testing context really easily. We've just found it to be a really great way to build a GraphQL server of your own. Second part of our emphasis on serverless is using something like CloudFront. And the apps that we've built with TGRS have been enterprise applications, and they've usually required some sort of a login for users because their usage is constrained purely to people within a business. And so when I've gone to infrastructure people within those organizations in the past and said, hey, we want to use CloudFront, they're like, but you don't need a CDN. Why would you want to do that? And to be honest, they're right. I mightn't need the scale of a CDN, but it is still, in our experience, just cheaper and easier to use something like CloudFront to distribute static assets. That's much better than having to, run your own Nginx server inside a container, inside ECS, and so on. That said, it's not always possible, and Aaron's going to come back to that a little bit later on. But definitely, if it's an option that's available to you, we highly recommend it. The last caveat on all of this, however, is security. So when you're using serverless services, pretty much by default, any API gateway endpoint, it's going to have a name, a domain name. Any CloudFront distribution is going to have a public domain name. So if you're in an environment, for example, that you want to constrain, like, a typical enterprise, it's really important to double down on security because you can't necessarily assume that you're just going to be able to contain everything to a VPC. So that usually means three things. HTTPS everywhere, which fortunately, using AWS offerings is just the default. And the second thing is we've lent heavily on WAF firewall IP rules to whitelist access to both our CloudFront distribution and our Lambda server. Another caveat of using CloudFront is that because it's out, in the public, even if you're using an IP whitelist, your API gateway endpoint is also going to need to have a public name if it's going to be accessed from there. So yeah, really important to set IP whitelists on that as well. And finally, we're just using a auth, some sort of auth system, being really careful about tokens, using Lambda authorizers maybe to verify tokens that are coming into your system, or using something like Cognito, really, really important. And I also just incidentally encourage people to, use on behalf of flows, for example, when passing calls onto other services from their GraphQL server. You really just, when you're serverless, you really just can't assume that your network is protected. You have to protect each component, on its own. That said, sometimes CloudFront isn't going to work out, and then you can still put the API gateway endpoint inside of VPC, which relaxes your security requirements a little bit, and we'll come back to that later on. So kind of putting all these pieces together in the context of this architecture, we sort of have, these two parts, a client and a server, and the client code will be all TypeScript, with React and Apollo client. The server will be TypeScript with Apollo server, and we'll have some build time process that bundles the client up with a bundler, compiles the server, produces a client.js bundle, produces a server.js bundle. The former gets deployed ideally to CloudFront, the ladder to a Lambda function. The end result from the user's perspective is really just a React app, and we know that it'll be talking to a GraphQL server over HTTPS. The fact that that server is in a Lambda function, the fact that the React app was served up by CloudFront, obviously, is of no real concern to our end user. But we know that by using serverless infrastructure, the majority of the time, especially for low volume enterprise applications, are going to reduce our costs and definitely are going to reduce our sort of ongoing maintenance requirements. The enterprise app that I'm working on at the moment, which uses this architecture and has moderately heavy usage, I think we're racking up about $10 a month, for example. Now, if you had a really, really high volume app subject to, lots and lots of concurrent users, you might want to be a little bit more circumspect about jumping straight into using Lambdas. But again, a caching strategy can often, in web applications, a caching strategy can often help with those sorts of problems as well. And it is possible to cache with GraphQL. So in terms of order of importance, in this architecture, I think TypeScript is actually probably the most important part, just because it keeps everything well behaved, keeps your code base maintainable. Next most important thing is GraphQL. Bit of a learning curve on it, but I think for many use cases, when it comes to building UIs, it's an improvement over using REST. I'm not saying GraphQL is going to take over the world or should be used everywhere. There's been a lot of talk lately about using GraphQL in federated graphs and so on. I don't know where that's going to go. But when it comes to the purpose for which it was originally designed by Facebook, enabling clients to efficiently and flexibly get the data they want over a network like the internet, GraphQL is great. Third most important part is serverless. There might be circumstances or environments where you can't use all the serverless infrastructure you want, but it's definitely a goal worth aiming for. And that's probably the fourth most important part is React. There's nothing in this architecture that prohibits you from using something like Angular instead. We have a little sample project set up for TGRS on our website. This is kind of just a little thing that shows how all of these pieces can hang together. It's a client talking to a server, which then forwards calls onto a mocked-up server. It doesn't actually have strong opinions about how you deploy it to the cloud, just because we know that everybody's environments are different. We may add a little bit of support for something like CDK just to kind of demonstrate how the Lambda function in there can be deployed. But we haven't been hugely opinionated about it so far. We're more interested in how GraphQL, TypeScript, React, and Serverless can all complement each other, which is definitely what we've found. And there are some extra things in that repo. We've got some browser testing examples. It's using Yarn workspaces. It's all kind of a mono repo with sort of careful dependencies set up between the different subcomponents. We use Create React App, which, if you don't know, is kind of like a Facebook framework for building a React app from scratch and taking care of a lot of the Webpack config. And finally, we have some examples of some of the code generation that I talked about, some tools that take GraphQL schemas and queries and produce types for them. So just to recap, TGRS is all about considering your UI to be both a browser client and a GraphQL server together, working together, worked upon by the same developers, UI developers, because that's really what we're building here. All other work can be pushed out to upstream REST services or other things, other GraphQL servers. But really, TGRS is about UI developers taking ownership of a client and a server. It's also about TypeScript everywhere, which is a bit of a learning curve, but we've definitely found to be worthwhile. And finally, it's about using serverless technologies where possible, because the cost benefits have just been amazing for us. And also, I think a lot of people underestimate the ongoing maintenance costs of having to, run your own containers and so on, run your own web servers, run even your own application servers. The less servers that you have, at least from my perspective as a UI developer, the less infrastructure you have, the better. So that's pretty much it from me. That's the high-level recap of TGRS. We have used it also at a government client, a couple of government clients, a couple of government client projects. And, in government, we don't necessarily get to make all of the infrastructure choices that we'd like. So Aaron's going to talk a little bit about how we adapted elements of this architecture to work in an environment with quite specific security needs. So I will hand over to Aaron now. Thanks.
Cool. Thanks, Ben. As Ben said, my name's Aaron. I'm a principal engineer from Shine, and I'm going to talk to you about how I adapted the TGRS stack that Ben just outlined to confine the web traffic from it mostly. And we'll get to the mostly part in a bit, because there is one small exception. So we were working on a project with AWS ProServe to deliver a data engineering project, so to build an operational data lake for a government client. And as part of this, we wanted to ensure that the project was as serverless as possible, such that they didn't have infrastructure and things to maintain, because it was coming up to quite a critical period for them. And we also, as part of this, wanted to include a web application to surface things like data lineage, transformation histories, and enable users to be able to search the data lake and find dashboards and data sets and transformations that they can use to really help their actually help them achieve their goals, and to be able to produce timely reports and actually derive insights quickly and reliably. Now, due to the nature of the project, it was designed to handle protected data. So as a result of that, in order to be hosted in the cloud, it needed to be IRAP certifiable. Now, if anyone's ever tried to get an IRAP certification for a project, you know that security has some really strong opinions on what they need to see, what they would like to see, and what they must see. And we had to do our best to ensure that all of these were met, such that we could be appropriately certified. So what were some of these requirements that they're after? Well, they wanted, first and foremost, they wanted all of the traffic for the UI to remain within its network. Now, I'll give you a brief overview of their network in a minute, but that includes their on-premise network and their kind of wider AWS infrastructure, so their VPCs and things. As I mentioned before, they also didn't want any additional instances to host the solution. So if we'd gone for the route of instances, then we would have more things to maintain, but also we'd then get into the whole kind of slippery slope of having to bake AMIs from golden images that they produce that would inevitably be, 3 versions older than a Red Hat than you really want, when you really want a fresh Amazon Linux 2 instance. So they didn't want to go down that route, and we kind of didn't want to either. Unfortunately, they didn't want to explore containerized solutions either, not for any technical reason, but just because of where they were in their journey. They didn't have the appropriate CI/CD tooling to support that. So in this context, we're talking about things like security scanning and artifact handling and that kind of thing. And whilst we could have helped support them to implement this architecture, that would have really led to some really extended timelines where when we thought we were building a kind of data lake with a UI component to help support that, we'd then be doing an entire CI/CD DevOps project first. So a bit of background on their infrastructure. So they've got a corporate data center where they host a lot of virtual desktop environments, and that's effectively where their users do most of their work. They then got this connected via a transit gateway to effectively a service account, where they host a lot of things like common VPC endpoints for services that they use a lot, Route 53 resolvers, so that they can resolve DNS from their different AWS accounts to on-prem, and on-prem things from AWS, as well as a couple of other services, but we didn't have too much of a visibility there. And then for each of the kind of projects that they're running, they had a separate set of AWS accounts that were then paired with this service account. So you effectively had near edge-to-edge routing from the accounts with application A and B in, through to on-prem, but not really to each other. So in order to answer their first point, what we're really looking to do is something like this. Right, we want traffic for our users to go across the transit gateway, through the service account, and then to some serverless infrastructure in our account. And where at all possible, we want to avoid taking the path where we go out through their web filter and their egress control across the internet and then back into our account. We want to really constrain it to, as I mentioned, that on-prem network, transit gateway, that service account, and then our account where possible. So it's 2021, and there are more options to host web apps than there ever have been, and more so in AWS than I think there ever have been. I saw the announcement of the white paper in JJ's slides earlier, which was one I'll go and read after this, but so those options not on this list. But you could do the classic S3 web hosting, in which you configure S3 to host a website, but unfortunately that's again serving over the internet, so that's really not applicable for what we're after. You could go ECS or Fargate, so you could bundle your application code and Nginx into a container, or you could use Apache if you wanted to. Put that behind a load balancer, as Ben mentioned, and serve the traffic that way. That would easily meet the requirement of keeping the traffic within the VPC, but then we're up for this CI/CD project to then ensure we've got the appropriate container build tools. And so similarly, that rules out EKS. Now, I think given where they were, EKS probably would have been a step too far, even if we had the container infrastructure. But certainly not having the container infrastructure within the client environment ruled that out from an early stage. So we could do some more traditional things. We could do Elastic Beanstalk, I guess. I don't know if anyone still launches new things on Elastic Beanstalk, but it's there and it's an option. There's a number of different solution stacks, but again, we're getting into the realms of having to maintain EC2 instances. Speaking of which, we could go straight EC2 instance. EC2 instances, application load balancer, kind of the classic 3-layer architecture. But again, we'd have to build SOEs for those. We'd have to patch and maintain them and ensure sufficient monitoring. And again, it becomes a real operational headache. So the approach that Ben outlined of, CloudFront for the static resources and then API Gateway for the GraphQL backend kind of works nicely. But again, to get to that CloudFront distribution, you have to go over the internet, which is not the path that we want to take. So maybe we could do API Gateway on its own, because that bit's not too bad. We can make that work privately. So it's really just the CloudFront bit that's the problem. So maybe we can work around that. So maybe we can try and put S3 behind API Gateway. Now I've taken the conceptual step and assume we're going to move to a private API Gateway just by default. So that's within our VPC net, or only accessible within our VPC. And then we can do some work to put S3 behind that. So what we can make use is of the proxy keyword in the API Gateway configuration to actually allow us to pass any paths that we've not defined directly through to S3. Now there's an asterisk here with a bit of fiddling, but you can kind of make that work, and I'll show you an example of that. You do have to be really careful with response types. So you need to make sure to pass the content type and content description back from S3 to the client, because that's not done by default. But you can make this work. It is worth noting that there is a 10 megabyte limit on a response that API Gateway will return, after which it just truncates. So unfortunately, it's not one of them things that kind of fails nicely or gracefully. So it is something to keep in mind when you're preparing your JavaScript build process, to make sure that, if you've got Webpack, or if Webpack is your bundler of choice, configure to produce many blocks of 10 meg rather than, thousands of, hundreds of meg of JavaScript in one bundle. So how do we actually use this proxy in the proxy configuration? So effectively what we do is we tell it that we've got some headers of content type and content disposition that we need to pass through to S3. And effectively we wrap that up so that all of the output is passed straight through So the integration response just passes the output of S3 straight back to the client. And we define a couple of models there for the 200 response, just to ensure that the headers come through correctly. But really, it kind of handles it nicely for you. Now, there is a couple of caveats here. If you're trying to do things like adding a rewrite to a URL, for example, if you want /sign-in to really return you the index.html because it's the beginning of your app, you'll have to add an explicit route for that here, or an explicit definition here. Similarly, if you've got a sign out URL for Cognito, you'll need to add that. So it is also worth mentioning here, the Cognito is the mostly part in the title. So we do accept that here, traffic to Cognito for the users will go effectively from the corporate data center out via the egress control to Cognito and then back to get the token. The client was actually okay with this because they had used Cognito for other things. So that was our one exception that we were allowed. So when we've done that approach where we've put S3 behind API Gateway, that works really well, except for the fact that you've got now a random URL for API Gateway that your users need to remember. Now, I don't know about you, but I've got a memory like a sieve, so I need a nice, fancy, easy to remember URL. Fewer characters, the better, and certainly something memorable with the name of the app in. So if you're looking through the console, you'll come very quickly across API Gateway custom domain. And so, it's like 5 clicks. You go, cool, here's the domain name I want. Here's my appropriate ACM certificate. And then you point it to your API Gateway and your stage. And at no point does it return you any errors. Unfortunately, if you do this, you will very quickly realize that you probably should have read the manual like I did, because there's one small issue. It doesn't work completely. Now, if you do read the manual, and if you're in the habit of reading the limitations section of the AWS manual, which I'll admit might be the section that people tend to leave the risk, it does actually tell you that custom domain names are not supported for private APIs. So bearing this in mind, we've really got a couple of options. We could have the users memorize the name of the API Gateway. I mean, I guess that is technically an option. I don't know many users that are going to accept it as an option, but maybe we'll park that one. We could give up. There's a not solvable problem. Maybe we need to reevaluate some of the requirements at the beginning and go, okay, well, one of these can't hold. Which one are we willing to compromise on? Or thirdly, we could try and find a way to call the API Gateway from within the VPC via the VPC endpoint that you've got it attached to. And so this is the approach that I went to. So when you create a private gateway, you have to associate it with a VPC endpoint. And that VPC endpoint then has a set of ENIs within your different subnets within your VPC. So maybe if we pass our requests through to those ENIs, because we've linked it already, it will just kind of know which API Gateway stage we're after, and we can work that out. Or maybe we could put even if we had to specify the stage, that's not terrible. We could work that out, but maybe we could do something like that. Just to rule out some of the other options, when you configure the VPC endpoint, there's an option for private DNS that, if you read the manual, looks like it should do what you want and allow you to put a custom DNS entry on this. It does not. What it's actually designed for is when you're creating your own services and you're creating a VPC endpoint service, to allow it such that if you share that with other people and they go to myawesomeservice.com, it redirects to your VPC endpoint rather than going out across the internet. So not quite what we're after here. The other thing you might want to try is Route 53. Going, cool, I'll just create a Route 53 an entry in a Route 53 hosted zone that says whatever my vanity URL is, CNAME, VPC endpoint. That also doesn't work. You basically get like a 403 for it not being the traffic not coming from within the VPC. So we really need something to make the calls for us within that VPC. So if we were thinking kind of traditional infrastructure and proxies and things, you'd use like Apache to proxy the request for you. But we're kind of not trying to, we're trying to go for a serverless approach. So we could try a load balancer. Now, application load balancers, you can't connect to VPC endpoints, probably for good reason. A classic load balancer really requires instances, and it's really insistent on it. But a network load balancer only requires a target group, and a target group only needs IP addresses. So if we can get the IP addresses from the VPC endpoint, then we can put them in the target group, and then we can have the network load balancer call that. And that kind of work. Now we can do a couple of bits to get that, but if you now just hit this network load balancer, it still doesn't quite work. You get a 404, like a not found, rather than the result that you would expect. So we're closer, but not quite there. So rather than go through all the steps, if we then bring back the custom domain option that the manual tells us doesn't work, there is a small amount of undefined behavior here. So clearly what must be happening behind the scenes is when you create these things, API Gateway then has an association between that host name and that API Gateway instance and the particular stage that you're after. Now, even though it's not resolvable by this approach, if you then point that vanity URL, that domain name, to your load balancer, mysteriously, this actually all works. So there is and so you actually end up with the traffic going via the network load balancer because you've got you're effectively got a host header with the right name. It then gets passed through correctly to your VPC endpoint, which then effectively ends up at your API gateway and then passed to either the S3 bucket or your Lambda function. So in this approach, we were able to actually achieve the goal of keeping the traffic largely, with the exception of Cognito, within the client's own network. So, and if you look at this through VPC flow logs, you can actually see the traffic come through the VPC when it goes to the application. You can't browse this application from outside the VPC if you want to do a test there, if you wanted to check that. And so we've really met the objectives that we were after, and we can use security groups on that load balancer and similarly on the VPC endpoints to really lock this down and make sure that only the IP addresses that we're after can connect to it. Now, one thing when you are building this is, okay, right, well, I've got this VPC endpoint, but I don't know if anyone's ever written CloudFormation for VPC endpoints, but it doesn't give you back the IP addresses because you're really not meant to know them or do anything with them. So one way around this is if you can write like a custom resource to look at that VPC endpoint and grab the IP addresses of the ENI and then make them available for further use in your CloudFormation templates. So yeah, some final thoughts. One disclaimer from me. If you don't have this set of constraints, probably almost anything else is better. You know, I would go with the approach that Ben outlined earlier of using CloudFront to serve the static resources and then API Gateway to then serve the GraphQL backend. It would really be nice, and you know, maybe I'll look at our hosts JJ and Brian to suggest this one. It would be really nice if this works correctly out of the box. Either if there was support for custom domains and private VPC endpoints, given that you really need an ACM certificate for it anyway. So I can't see a reason why it couldn't work internally. Or to make it a lot easier to more strongly attach an API gateway to a VPC. And if you are curious about how this all works, then there is a CloudFormation template that I've put as a GitHub gist that does explain this. Cool. So with that, I'll hand back to Brian for any questions. Cool. I did. Yep. It is possible that they could change. I haven't seen them change regularly, so it's been running for 12 to 18 months now, and they haven't changed, but there is the possibility for that. Now, you could work around this by, instead of deploying it as a custom resource, maybe a Lambda that kind of monitors the IP addresses and updates the target group for you. And you can run that like every, whatever your level of comfort is. So you could run it every hour, you could run it every 10 minutes if you wanted to, as an approach to making that a bit more reliable. But in the time I've kind of seen it run, they've not changed.
Any other questions for the guys before we wrap up? All right, just 1 second. We're going to swap back to JJ to wrap up for the evening.
Thanks, Aaron and Ben. Great talk. I think I'll actually might present to a few of my customers the option of just giving up because it's not a solvable problem. That was a cracker. Well done. No. Okay. Thank you, everyone, for tuning in. As usual, let us know what you'd like to hear. We love running these events. We love having our customers and our partners like Shine Solutions up and talking. So absolutely, let us know what you'd like to hear, and let's make this content exactly what you prefer. We are trying very hard to get back in person. We know that's what we actually want to do and be, so we will make it happen as soon as possible, everybody. Also, please submit your feedback. So the Meetup app will ask you to put some feedback into the event. We will read each and every one of those. So please definitely send it in. We'd love to hear what you have to say about it. And finally, friends don't let friends miss the AWS Canberra user group. Please tell your friends. Word of mouth is our best way of marketing this event. So please let others know some of the great content you've seen tonight and get them to tune in into future events. And with that, we're kind of done for the evening. Thank you very much for tuning into our October session. We really look forward to having you for at least one more event later next month, just before reInvent kicks off. So that would be ideal. Have a great month, everybody, and we'll see you around. Thank you very much. Good night.